This is the first video in a series on generative AI learning and equity. In this series, we strive to understand the nature of generative AI and what that means for how we can use it in education and the consequences for its use in education. My name is Melissa War. I'm from New Mexico State University. I'm part of the Biased AI and Systems of Education Research Collaborative, and part of this project is funded by the LASL Equitable AI in Education Initiative. This video focuses on understanding the nature of AI and to acknowledge Punya Mishra at Arizona State University has worked with me and came up with some of these examples himself. And so we collaborated, and this is the result of a lot of our collaborations. So, first, which red dot is bigger? Now, you might have seen it before, and you might know that even though this one on the right looks bigger, they're really the same size. It's an optical illusion. But if we were to give this picture to something like ChatGPT, would it fall for this optical illusion? Well, in this case, it didn't. It says it demonstrates an optical illusion known as the Ebbinghaus illusion. And it goes on and gave us a great explanation of why it might look differently. Pretty smart, right? Chatbots, which we're using it as an example here, are smart. But what if we did this? Punya Mishra created this, where this circle is, I promise I'm not trying to trick you, it really is bigger than this circle. It's not really an optical illusion, although it follows the pattern of an optical illusion. What would ChatGPT say? Well, in this case, it said it's another example of the Ebbinghaus illusion, and it goes on to explain it. In fact, I asked it, are you sure that that's another example? And it said, let me do some fancy coding thing. And then it said, oh, yeah, see, one's 51 by 50 pixels and the other's 50 by 50 pixels. So they're nearly identical. Now, think about it. Does it make sense to measure a circle using 51 by 50? Normally, we look at the diameter or the radius. Why in the world does it think it's going to do something by something, especially if it created some calculations? That's because they're drunk. Chatbots are drunk. They make weird mistakes that are hard to understand sometimes. So then I said, are you really sure it really looks different to me? And it says, let me verify again. He said, oh, okay. Actually, the right one is 50.5. And the left one is 50.5 and the right is 50. Well, that's nice that it's, adjusting a little bit when it looks again and not just telling me the same thing. But there's not such thing as half a pixel. Then I said, I really think you're wrong. And so it's going to completely rule out all doubt. And it does some funky image thing and says, see, I told you they're the same size. Chatbots are supremely confident. Okay, so we've got smart, drunk, and supremely confident. Now I want to show you another example of what we can get from chatbots. In this case, I asked ChatGPT, I said, I want to write a book about a family creating classical music. Can you create a cover? And this is what it gave me. Nice little families creating classical music together. Then I changed one word. Instead of classical music, I changed it to rap music. And this is what I get. Classical, rap. So we notice the difference in the style of images, but also in the race of the participants. Even though we know that those who are white can also create rap music, there's a general sense that perhaps it's more common with people who are black. And that's what it does, is it associates that rap music with the black race in some ways. Well, let's use this to try to think about what might happen if we're trying to personalize the chatbot to our instruction. So this is Khan from Khan Academy. It's an AI assistant, and you can personalize it by telling it what your favorite hobby is. So let's pretend that one student says, my favorite hobby is classical music. And it's trying to get feedback from a large language model like ChatGPT. And so it gives it a writing sample and asks for personalized feedback and a final score. Now, we know that language models and really all generative AI, it's generative. So it can be slightly different every time. So we have to do it a lot of times to see what maybe an average score would be. Now, that's for classical music. What if we change one word? We change rap music. We give the exact same student writing sample as we did with classical music. We just said the interest was different, right? So if they're the same writing sample, they shouldn't get different scores, right? Well, they do. It can be a subtle difference, and it varies by model and such, but on average, it gives the classical student a higher score. Chatbots are biased. They're smart, drunk, biased, supremely confident interns. Why? Why are they that way? Well, Leon Furs says chatbots don't make sense, they make words. They're putting patterns of words together. So, how do they make words? Well, try to fill in the blank. Mary had a blank. If you're in the United States, you probably think Mary had a little lamb, right? Because that's something you've heard a lot in your life. What large language models do is they guess the most likely words that are coming up after other words at the most simplest level. If it's something common like this, it's going to put something common to the culture of the data it learned from. And we'll talk about that data in a minute. But what if it was something like this? Josh had a. In this case, we probably all think of different things. There's not as much of a pattern here. But even though there's not as much of a pattern, the AI doesn't know that. It continues completing a pattern, even though there's no real cultural pattern necessarily to this. Okay? So the question is, where does it get these patterns? Where does it get its information? And how come it's right so much of the time? Well, let's consider this. What if we said, what are the 5 most likely words that come after Lincoln was born in? Because, that's what it's going to do. It's going to guess the most likely next words and put them all together to give us a response. Well, in this case, it gives Kentucky, 1809, February, log cabin, humble family. All of them seem to be pretty correct. In the data it was trained on, the data that it's based on, there was probably a lot of books and a lot of websites and a lot of talking about Lincoln. And so it has a lot of information, and that pattern is going to repeat. The AI doesn't know that, it's just repeating a pattern. Well, let's switch it up. Let's say words associated with Melissa War was born in. This time, it doesn't get any of them right because that's not as substantial of a pattern in its data. Just like a Black student, a rap music is very common with a Black student, even though it's not necessarily true. It's a pattern in its data. There is so much data that they get trained on and they learn from. This is ChatGPT 3. This is before, even in 2022 when it came out and made a big deal in the world. This is before that. You look at this 3%, all of Wikipedia is just 3% of what it gave. And then this is ChatGPT 4. Now, we're not even using ChatGPT 4 now. I just don't know how much data they haven't published, or I haven't found the difference. But you see the scale difference. There is so much data in here that it's impossible to really curate it nicely. It's primarily just all the stuff on the internet. Here's another way to think of it. As humans, we form internal representations of the world. Those representations are based on reality, the things we do, the things we see, the things we experience, and our senses. But it's also connected to things like books we read and songs we hear and conversations we have. Those things are external representations that other people or even ourselves have made. So someone writes a book, they take their representations or ideas and they put it externally. And we learn from that, but we also learn from reality. Well, large language models, as well as pretty much all generative AI, learns only from external representations. In fact, it's not even all the external representations, it's just the one in its training data, that although that is a lot of data, it's still only things that have been on the internet, which isn't necessarily equitable. A lot of people's information isn't as present, or their culture or their patterns of life or their uniqueness might not be represented. And so they're not represented in the models. And that's why sometimes it can seem drunk. It doesn't actually see the red dots in the Ebbinghaus illusion. It just is looking at the pattern where we have black dots around a red dot. And it's just pulling from external representations other people have put out there. Here's another way to think about This is my great niece Nora. She was 2 at this time, and this is Bryce Canyon in Utah. And we were hiking in Bryce Canyon, and we were somewhere around this area, and there was a fork in the trail where we had to choose which trail to take, to the left or the right. And I said, which way are we going to take? And Nora said, Melissa, you go left, then right, then right, then left. I read the map. And my first reaction was, Nora knows left and right? And her father says, she's a lot like ChatGPT. She wasn't necessarily lying, but she was repeating words that she had heard others choose. Now, she had experienced hiking, but she hadn't actually experienced reading a map and choosing which way to go. So she's just putting together hiking, that pattern, with where to go in the map and left and right. And that's basically what these AI models do, is they just put together these patterns. They don't have any real connection with reality, even though it's amazing how often they're right. Here's another example. I asked ChatGPT to make a lot of clocks that say 3:14. And this can be different times you do it, but this was one time, actually the first time I did it, and this is what it gave me. There's a lot of really nice clocks here, but none of them say 3:14. In fact, they all say 10:10. Why in the world would they all say 10:10? We know as humans that it's only 10:10 twice a day, but it's putting it every single time. We also know as humans, we experience every day, we know that 3:14 is a very specific time. It's not just any random time on a clock. Well, if you think of the data it was trained on, it might look something like this. This is from Google Images. And you see here that a lot of the clocks say 10:10. Not all of them, but a lot of them. It's going to follow that pattern because it doesn't understand that clocks actually have time. It just looks at that pattern of what a clock is. Here's another example. What if I asked it to grade something? And I asked it to grade this, and we know that, let's see, this one's wrong, and this one's wrong, and this one's wrong. So it should be 40%, right? It should be 2 out of 5, correct, 40%. Well, I asked AI models to grade this a whole bunch of times, and this is what I got. Gemini gave 20 every time. ChatGPT 4.1 Nano gave 18.3 every time, and Sonnet Claude gave 100 every time. It's a relatively simple thing to grade, but it doesn't understand that there's an exactness to this because it has never counted on its fingers. It's never done things with numbers to understand that they're exact things. It's just still following patterns and repeating patterns. Now, it's still going to probably get a lot of things right because these are common addition problems it might have seen, but it's also trying to think of what grades look like and, oh, it doesn't seem like they're all quite right, so I'm going to give a low score, or, let's just give them a high score. I don't know why it does it, but it's following patterns. I can use something more specific and say, you're an expert math grader, you pay close attention to accuracy, grade the math test, counting the correct answers, then giving the total. And I said, even give an example, 2 for 5 equals 40%, and it goes through and it does this really nice thing, but it still says this one's correct. So even with what we call better prompting, it's still getting the numbers wrong. Like I said, it never counted on its fingers and toes. It never split a pizza with friends. It never sang 99 bottles of beer on the wall. It doesn't understand that connection to the actual world. So what I like to say is that while AI is very powerful, and in other videos we'll talk about how it can support creativity, it can help us learn, we want to use it when accuracy doesn't matter. And we want to use it with a mindset that we don't depend on the accuracy, we use it more as content to think of. So we'll talk about that in future videos. Thanks for watching.